Hello, everyone. Welcome to our webinar, Austin Engineering Buckets What Matters Most webinar. My name is Sam Sakasiris. I'm the National Team Leader at Ostmine, and I will be your host today. Before we begin, just like to acknowledge that I'm hosting this webinar from the lands of the Whadjuk Noongar people and pay our respects to elders past, present, and emerging. In this webinar, Austin Engineering will share the practical lessons behind the evolution of its bucket designs from classic heavy-duty builds to today's linerless and modular systems. The format of today's webinar consists of a presentation followed by a Q&A session. If you have a question for any of the presenters throughout the webinar, please type them into the Q&A box at the bottom of your screen. If your question is directed to a specific presenter, please note their name in your question. And for your information, this webinar is being recorded and will be available for on-demand viewing to all people registered today. Joining us today from Austin Engineering, we have Jamie Hall, Innovation Manager, with over 34 years at Austin Engineering. Jamie Hall has been a driving force behind the company's most significant engineering innovations. And Brad Higgins, GM Sales for APAC and EMEA. Brad brings over 13 years of leadership experience at Austin Engineering with a deep understanding of both operational execution and strategic growth across global markets. That's the end of the welcome introductions. So without further ado, I'd like to welcome our presenters, Jamie Hall and Brad Higgins.
Yeah, thanks for that, Sam. It's a privilege to be here today and represent Austin and obviously Ostmine. We've done a lot with the Ostmine group in the past, so it's fantastic to be invited here to speak. And today, I guess, we'll get through all the slides. There's a little bit around bucket design, and then there's a touching on the different Austin product and where we've evolved our designs, so to speak. Just make sure. Oh, I've clicked on too many slides. Here we go. So I guess, look, there's two of us presenting today, myself in the sales type role, but the man on the screen in front of us and a very close work colleague of mine, Jamie Hall. He is the brains behind our designs. There's no hiding that. He's not a man to speak about himself much, but I'll happily sit here and talk his praises. Jamie's been with the Austin Group 34 years, just over 34 years. And as you can see there by the bullet points on the screen, he's been across more than 800 buckets designed in his time with the group. He's there holding an award, as he's pictured there, for his work done with the HPT truck body design. And Jamie has been across all of the products from tyre handlers, water tanks, buckets. But I guess he really, his passion is there, right there with the buckets. He's got over 18 global product patents to his name, and that's a credit to the role that he plays here with Austin as a global innovation manager. Although we won't give away all our trade secrets in today, Jamie is going to touch on some of the major design concepts that we think about and what really does lead to a successful bucket being developed for our clients. So over to you, Jamie.
Oh, well, thanks, Brad. Welcome, everybody, and thanks for joining, and also to Ostmine for hosting the webinar. I'll jump straight into the slide because I know we've got quite a bit to get through this morning. So the first slide, this highlights the critical site-specific and operational considerations that need to be addressed in the mining bucket design process. It reinforces the idea that the bucket design is not purely geometric, it's an engineered response to material behaviour, equipment interaction and site strategy, all of which influence the final product configuration. Now, looking at the key factors on the screen that influence the final design outcome, we have location and commodities mined. This is the type of material being extracted, such as coal, iron ore, copper, or whatever. And its location helps to determine the bucket structural material selection and wear protection strategies. The bulk loose density or specific gravity, this is one of the most critical design inputs we need. This directly affects payload calculations and bucket sizing. Fragmentation size and material impact and abrasiveness. This influences wear liner layout, lip system selection, and any structural concerns. We consider bench heights and fill factors to optimise digging efficiencies, and pass matching to haul trucks. This is essential to operational efficiency and ensures the bucket's capacity aligns with the truck's payload in a target number of passes. Mine strategy and service life. This affects choices around bucket robustness versus weight. For example, Some operations prioritize durability and long service life, while others focus on cycle times and payload. So in summary, all these factors come together to guide us towards the best possible final design tailored to each unique project. It's essential to recognise that there are several aspects that play a role in establishing an accurate and comprehensive foundation for a bucket design. We have things such as loading tools. Details as the make, model and serial number are critical for identifying the specific equipment configuration and ensuring precise compatibility with a proposed bucket. Also, machine type, whether it's an excavator, a hydraulic shovel, wheel loader or a dipper. Understanding the type of loading tool is fundamental, as each has a unique operational characteristics that will influence the final product. Existing bucket, are there any existing buckets on site? If so, how are they performing currently? This is invaluable information for a bucket designer. What is the volume? What wear characteristics are evident? And what ground engaging tools are fitted? These are all important factors to consider in order to optimize a bucket's performance. Understanding machine parameters like maximum suspended load or rated suspended load, and the machine's operating envelope are critical details to understand in defining the machine's limits and capabilities. All these elements together form the core of the design baseline, and considering each one thoroughly ensures the development of safe, effective and tailored solutions for the end user. Now moving on, excuse me. Now moving on to how we select the right GET or ground engaging tools. Austin remains indifferent to any particular brand of GET. This slide highlights that the selection process is quite flexible and it really depends on a few key factors. First, we look at the brand or type of GET. Different brands might offer different features or compatibility. We then consider what best suits the specific application we're working on. For example, the type of terrain or the kind of work being done can influence our choice. Customer preferences are also important, where some clients might prefer certain designs or hold stocks of a particular system and would like to see the standardisation across their fleets. Mass considerations. GET weight contributes to the overall bucket mass and affects payload. Overly heavily GET can reduce payload capacity or tip the machine over its safe operating limits. The operating envelope. GET selection affects tip radius and dump clearance, which must fall within the machine's operating envelope to avoid clashes or restrict movement. So by considering all of these factors, we can select the most appropriate GET for each unique situation, ensuring efficiency and durability. The major point to consider is that we focus on what works best for the specific application. This slide highlights one of the most fundamental aspects of the bucket design process in establishing the operating envelope. The operating envelope defines the physical and functional limits within which the bucket must perform, and is crucial to ensure machine compatibility, safe operation, and optimal productivity. By carefully considering parameters such as width, height, depth, machine attachment points, tip radius, and range of movement, our clients can ensure the bucket is fully integrated with the host machine's kinematics, will be free from machine component clashes, and complies with OEM operating standards.
Thanks, Jamie. Just jump on. Thanks, Jamie. I guess this slide here, just following on from what Jamie's just spoken about, this bucket on the screen is a classic example, and we've got a case study of this bucket further on in the presentation, so I won't touch on it too much now. But I guess all of the design parameters that Jamie has just spoken about really comes down to that relationship with the client. So as you can see by the bullet points on the slide here, realistically, the closer we are to the end user, and we've got a lot of educated end users out there at the moment, and there's a lot of data driven from these attachments that help, plan out mine strategies and future dig sites. For us, I guess the message that we want to get across is the more transparent we are with our, transparency from both ways between Austin as the customized attachment provider, in this case on buckets, the more frontline insights we get from the guys that are actually swinging the tools out there, doing the maintenance, the people pulling the levers, operating the equipment. Now, the more information and data that we have there, it allows our engineering team to really look and model the right outcome for you with your particular bucket. So more foresight, closer relationships, and then we can bring you along for that journey and model the attachment to really suit your mine strategy and optimize both the bucket and the match to the hauling fleet as well. Okay. This slide here sums it up pretty simply. A lot of people think, you kind of get a payoff between productivity and payload and reliability and longevity. And in some cases, that is true in those really kind of harsh digging environments. I guess what we focus on here from Austin is we want you to get the most out of your asset. So for us, it's all about the total cost of ownership, that little white square or triangle diamond shape in the middle there. So on the right-hand side of on the left-hand side of the screen there, you can see that we've got a linerless Liebherr bucket there. That bucket there was quite a heavy-duty bucket shell. So a 50 mil bucket shell on that particular bucket, that's done over 17,000 hours maintenance free. So the customer wanted a productivity increase, and they wanted a bucket that would meet the operational needs that they had for that site. But they also wanted it to go a certain distance, and we were able to achieve that. So hence the reason why it's not always, about a heavy liner and there's a trade-off there. There is not if we're closer to the end user and understand their requirements. On the other side, there's a face shovel there. You can see it's an old photo there with a whole heap of liners all over it in that particular application. And that bucket there was operating in a highly abrasive mining operation. And there was the need for, longevity. They wanted that bucket to go the distance. So we were able to think about the wear package that we applied, think about the shapes, think about the sizes, think about ease of maintenance. But I guess on this slide here, again, typically, productivity is what we're all there to do. We're there to make these attachments more efficient, dig better, dig faster, better fill factors matched to your haul fleet. On the flip side, we are also able to make them go the distance. And for us, it is all about that total cost of ownership for you to really get bang for buck when you invest your money with Austin on a mining attachment. Okay, and this slide here basically covers what we touched on the last slide. So we can design, again, understanding the fragmentation, the operational needs of that attachment. We can build for wear. So even though we're going to be talking a lot about linerless buckets today, we can scale up or scale down the particular bucket. And we'll talk about 3 later on in the slides, but we can scale up the thickness of the shell. We could look at how we armor that. We can look at the design of that bucket for it to go a certain life expectancy before a refurb. And then we also think about the ease of maintenance. So we understand that there's a lot of challenges with doing refurbishment type work on a mining site, and we try and factor that into our overall design. Okay, over to you, Jamie, in regards to the structural integrity of the bucket.
Yeah, thanks, Brad. So when designing for structural integrity and longevity, it's essential to evaluate the overall load-bearing capacity and resilience against operational stresses and wear. The selection of construction material types plays a critical role, focusing on those provide maximum strength and durability, such as high-grade structural and wear-resistant steel or a combination of. Plate configuration should be optimized to distribute stresses evenly and enhance structural stability, ensuring effective load transfer and resistance to deformation. Additionally, choosing appropriate welded joint configurations is vital. Understanding operational dynamics improves joint strength and minimizes potential failure points. Together, all these factors contribute to a robust, long-lasting structural design that meets the client's expectations along with safety and performance standards. Next slide, please, Brad. So this slide effectively outlines the comprehensive design verification process used by Austin in developing mining buckets, demonstrating a structured and technological robust workflow. It highlights 3 core stages of the design process, each leveraging specialized software tools to ensure performance, reliability, and efficiency. So we have 3D design modeling. The software we utilise for this is a full-featured 3D CAD modelling package called Creo. This is the initial stage involved in creating a precise digital model of the bucket design and enables our engineers to visualise the geometry, plan for component interfaces, and prepare the model for further simulation. We then put this through a DEM loading simulation. The software we utilise for this is a discrete element modelling tool called Rocky. This simulation stage focuses on understanding how the bucket interacts with granular materials. It validates volumetric capacity and also establishes realistic loading conditions by simulating particle behaviour inside the bucket surfaces during operation, which is then transferred to our FEA analysis tool. And finally, our structural analysis. The software utilised for this is ANSYS finite element analysis packages. In this phase, the design is tested under realistic load cases to evaluate stress distribution and identify potential fatigue areas. ANSYS simulations help predict the maximum fatigue life of the bucket, ensuring that the structural integrity is maintained in demanding operational environments.
Okay, I guess this is where the sales pitch part of the presentation comes in, but I guess what Jamie has just spoken about then in regards to all of our buckets being thoroughly examined, the thought process around the makeup, the weld joints, the shape, the configuration, the plates used is all absolutely critical. And we do here at Austin have, I'll focus on the excavator bucket backhoe range today. But the three pictures in front of you on the screen right now are three linerless style of buckets. We've got the JEC, Jones Engineering and Cranes type traditional style of bucket that we're very famously known for. We've got the HP series, which is the high performance. You've seen some of those photos through the slide today. And then, of course, we've got the Hulk, which is a Maintech product. And Austin successfully acquired Maintech a couple of years ago now, and a very welcome addition to the Austin family. It kind of complements the full range of excavator buckets that we have. So if I was to dig a little deeper into those products, the Hulk, the whole concept behind the Hulk bucket is a linerless style bucket to really optimize your material flow and your dig on site. So traditionally, the Hulk bucket was brought in to really enhance and look at larger volume buckets and look at the way that it moves that waste ore, really high strip ratio, large bucket fills, good fill factor. And the Hulk bucket has a couple of really unique advantages on it. You can see there one of the bullet points talks around reduce of hang up. One of the advantages of the Hulk, it's got a cast left and right hand cheek plate. So there's some large radiuses inside the bucket. There's no square edge inside that bucket to allow that material to displace from the bucket when emptying. And it works well in those stickier type environments. It also lends itself, if I go to the next slide, to ease of maintenance. So these Hulk buckets, they've got castings in that upper torque tube area, and they've got the castings on the left and right hand side cheek plates. And you can see that segment there that has been discharged from the bucket just to really show you the ease of refurbishment. So typically, these buckets here are designed for that 35,000 hour type, longevity in the asset. And to maximize as much material movement in that time. So there'll be a set kind of parameter that we set around refurbishing, and we're able to scale up, scale down that thickness of that plate, the shell plate in the back end of the bucket between the two cheek plates there. And we can customize that to be as light or as heavy as it's needed for the potential application that it's going into. And obviously work within that RSL of that machine that Jamie had spoken to. So maximize the size of the bucket, work within the RSL of the machine, maximize that fill factor, and the benefit of those castings on either side and the ease of refurbishment really lends this to those customers that want that high performance dig bucket. They're happy to take the bucket off and do that ease of, quick turnaround maintenance style regime on the bucket and get it back into production. So linerless bucket, it does have some of those green hockey sticks and boomerangs in the high weld areas to help protect some of the weld zones and those corner pieces that you traditionally see wear in. But all in all, this is a a non-fuss, high production, move dirt, take it off, refurb it quickly and get it back to work style of bucket. Just go to the next slide. Okay, the JEC HPX. So this bucket here, again, very unique. The Hulk has the castings on the left-hand side and the right-hand side. This is a truly completely fabricated out of quenchins tempered steel bucket. So we got a little bit more, I guess, flexibility in the shape of the bucket. And we typically traditionally, buckets that this bucket was born to go up against would be linered, high wearing, gold mining, iron ore mining type applications. And when customers came to us and they wanted a different solution, again, maintainability, we were able to come up with the HPX to be able to allow those black segments there with the cheek plate and the rear liner section. So we can, again, scale up, scale down, depending on what kind of digging application the machine's going into. So either go heavier for the iron ore and the gold and lighter for the coal mining type applications, or high strip ratio of waste material. You can see the red segment at the top there. A lot of the times buckets were being returned to the Austin workshop to do maintenance on. And we would typically see in other buckets out there on the market, you'd see a lot of cracking in those type areas up in those top hinge sections. So we've got a robust kind of top hitch connection plate that doesn't need much maintenance because it's built tough. And then you can see that light grey skeletal frame, and that is quite a thick structure, again, suited to the application. But because it's a fabricated bucket, you get the flexibility of being able to control the curvature and the shape of the bucket, and you also get the ease of maintenance style. So again, this can either be taken off site, sent down to a refurbishment facility where we can quickly chop and change some cheek plates and some liners, or alternatively, you can fabricate a whole new basket bottom section where it's just take it away from the top red section, weld it on and get it back to work as quickly as possible. So a bit of best of both worlds with the HPX. And then, of course, I guess the heading says it all here. JEC is, I guess, our legacy bucket in regards to the fact that we've built more of these than any other bucket in Austin's time. The JEC, as I mentioned at the start, John's Engineering and Cranes, I guess there's a real proud history there of these buckets out there in the field. They were traditionally built here in Western Australia and shipped all over the world. They're hardy, they're tough. We have also got a lineless bucket. That bucket that you've seen earlier on in the piece on the Liebherr machine is a 10-year-old JEC lineless bucket that's still out there performing. And you can see the blue section there, very easy to cut that segment away, replace that bottom section, that basket. We also see customers that want wear packages attached, very easy to create a wear package to suit this bucket, to suit different applications when the mining gets tough. But this one here, Jamie's pretty much single-handedly had a finger in all the designs of these buckets that have left the Perth workshop. And I'm proud to say that some of these buckets out there in the field, we still come across buckets that have been out there for over 20 years and they're still going around and getting refurbed. So very long, proud history of this bucket. And the JEC does not need to always be a linered bucket. We're getting great success rate with lineless. As well as our bucket range, we go into the underground. So the case study that I mentioned at the start and getting to know our customers and understanding our customers' need, this is a little bit of a case study. So this is an RH or an R3000 underground cat loading machine, bogger. This bucket here, the customer came to us, he was quite educated and he knew exactly what he wanted. And he came to us with a couple of, design considerations. Number one, he was adamant with the GET that he wanted to use. There was some castings that needed to be used in the corner. There were some safety design features that he wanted captured in regards to how he handled these buckets. This was a block cave gold mining application. This customer here wanted to extend. He had a series of these machines on site and he wanted to go past a 5,000 hour maintenance interval. He was seeing that the bucket that he was using on the machine, first fit, was getting to 5,000 hours, and some of them weren't quite getting there, and that was where his large maintenance interval was. And he came to us and he threw a challenge to us, and he said, I want to see these buckets go 10,000 hours. We weren't allowed to budge with the volume on the bucket. It had to be 10 cubic meters. So we had to maintain a 10 cubic meter bucket. And we worked with this customer week in, week out for a month or two, until he was happy enough to go to production. Now, the result of that and the transparency with this customer, including hours and hours of operational video of how the machine performed, we were able to give him a bucket that not only met the 10,000 hour maintenance free, but it surpassed that, and they were getting to 12,000 hours maintenance free. Other than changing the GET, they were able to get this bucket to that sort of life expectancy. It is a linerless bucket. We were able to meet the capacity that the customer wanted, and we were able to give them a 20% productivity gain just on the way the material flowed in and out of this bucket. So their cycle times were faster. They were going in once clean, they were picking up the material, and they were being able to move out. So I guess the point here is the gains, the numbers that we've got on the screen are factual. We were able to work very closely with the customer. That is the reason why people come to an aftermarket customized, attachment provider. And going through understanding the challenges and getting to know what the customer wanted, we were able to not only achieve that, but we were able to surpass that. And that was with a full linerless design. So absolute credit to Jamie. Privileged to be a part of this project, and a privilege to see that these buckets have continued on for that customer out there in the field. Now, of course, we not only supply the buckets, but we have a full range of pins and parts. And I guess what this presentation doesn't quite clearly articulate, but there's a lot of thought process that goes into these supporting components with these buckets. So aluminium end caps, right down to the way we bolt the end caps on, the pins that are being used, the way we're greasing the pins, and even down to some of the wear components there that you can see items 16 and 17 at the bottom of the page around hockey sticks and wear components that go in the bucket. So I guess when you come to an aftermarket supplier like Austin and we design a bucket for you, it's not just pick up a bucket and you go and reap the benefits of the dig attachment. It's around all those supporting components as well. And we also have a whole heap of safety stands and bits and pieces through our main safe support function, where we can actually give you some tooling and some safety parameters to be able to change those components out. So this is pretty standard dealing with Austin. You get a full parts map on any of those components that we supply. And I guess, Jamie, I'm going to throw it back to you, mate, with the four main bullet points that we want everyone to leave the presentation with remembering today. So I'll leave that up to you to finish off, Jamie.
Thanks, Brad. So to wrap up the presentation and capture all the key takeaways, this slide really captures the heart of our design philosophy. It's all about adding value at every step. Firstly, we don't just work for our clients, we work with them. True collaboration as partners. Secondly, we make sure we do our homework before putting pen to paper, collecting the right data up front so the design starts off on the right foot. Thirdly, we design to suit, ensuring everything aligns with the RSL of the machine and interfaces perfectly with the OEM specs. And finally, we design with purpose. Every choice has a reason behind it, tailored to the real-world applications. At the end of the day, it's about smart, practical design that delivers real results. And then that really concludes our presentation. So thank you for listening.
Thank you very much, Brad and Jamie. Some amazing innovation from a great success story for both Western Australia and internationally as well. It's now time for the Q&A. If you haven't already submitted a question, please use the Q&A button at the bottom of your screen. And I do have a couple of questions that have come through. What does AustIQ compatible mean?
Yeah, I'll jump in there, Sam. So AustIQ is the current platform that we use for, thickness testing and recording the buckets and our truck bodies. So at the moment, We've got a pretty unique platform that has been running for about 4 or 5 years, previously known as MainTrack, now converted to AustIQ as we've developed it further. So at the moment on the buckets, there's traditionally a visual inspection and a thickness inspection, and we've got a pretty unique system of recording that and spitting out reports pretty quickly. But I guess just to go a little bit further, Sam, at Diggers and Dealers this year, pop by the Austin stand, and we've got a little bit of an official launch. So there's some exciting news coming out in regards to the technology that we're going to be using on our attachments in future. But I won't spoil that. I'll let everyone pay for their ticket and come out to Diggers and Dealers, pop past the stand and catch up with us. But yes, it is a AustIQ at the moment. AustIQ compatibility is around the inspection of the asset and recording, and capturing the life of that asset at the moment.
Thanks, Brad. Next question is, will there be any sensors installed in the basket, like XRT sensors to tell which specific kind of ore is in the shovel?
That's a great question, and I'll happily answer any of those at Diggers and Dealers with the launch of our next innovation. So come and see us. But yeah, if you're in Kalgoorlie this year, pop by the stand, and we'll happily talk a little further around what the future of thickness testing means for the Austin product range, and not just our products.
Thanks, Brad. Next question. How flexible are you at adjusting the tip radius and angle of attack to increase the volume of the bucket? Does this affect the digging performance?
You want to jump in there, Jamie, for that one?
Yep. Well, tip radius is quite critical. Like I sort of mentioned a little earlier, tip radius really needs to be adhered to, and the angle from which is set from the OEMs to make sure that when the bucket crowds, that there isn't any machine clashes or anything like that. Tip radius also could be adjusted to change the diggability of the bucket, or how the bucket performs when it's digging. So shortening it may help it out, and it just depends on what application we're looking at.
Thanks, Jamie. Next question I've got here is, how does fragmentation size, impact, and abrasiveness influence the design choices?
All right, I can help answer that. Again, it's getting to understand fragmentation. I mean, if we're filling buckets with Land Cruiser size rocks all the time, your fill factor's not going to be 100% every single time. But I guess more to the point, Sam, is if we can understand what the current and future dig are, we kind of the commodity, the fragmentation, to where over a period of time. It's about understanding the full dig cycle before we go and create that asset, that bucket, create that. There's a lot of I guess design concepts that go across all three of those, but they're a huge factor. I guess it gets back to that density, like Jamie spoke about at the start, to understanding right at the start, getting the right. Anyone can go and scan a bucket tomorrow and come up with a bucket to try and suit one application, but ours are more customized to suit the particular commodity and dig.
Thanks, Brad. Next question is, how do current wear trends affect the selection of bucket components?
It's a good question too. That really comes down to talking to the customer, because it depends on whether they're going with a linerless bucket or whether they're going to armor it up. Some of our customers at the moment, for instance, we've got one in Africa at the moment that they're adamant that they want a wear package on it, and we'll work around the wear package to suit where they're seeing wear, and we can account for that at the start, versus some of our other customers understand that they have high wearing sites and they're happy for a bucket to go 6,000 hours. So again, that really comes down to that first communication with the customer, understanding what they want the bucket to do, and then bringing them along for the journey. They can then make the decision with whether they want to take something off every 6,000 or 12,000 hours and do a refurb, or whether they want to be able to do some of that maintenance on site. So again, it really is specific to each customer. It's not a generic style, one fix all.
Thank you. Next question I've got here is, how does the choice of GET brand or type affect the equipment performance?
So we are, as Jamie mentioned, we're indifferent. We have some pretty close working relationships with some of the GET brands out there. And there are some that are definitely better than others. There is from our side, Jamie, you might want to jump in and help, but There are some GT brands that are a little bit more forward thinking and a little easier to work with, and we can easily work with them and get the right model. Others are a little less, I guess, advanced in their train of thought and way of thinking. And again, it comes down to some customers have a preference due to commercial terms as well. So depending on what part of the world they're in, what access they have to GET, sometimes we'll build a bucket, we'll be able to maximize the GET that they want on that particular bucket and exhaust it to be, efficient in the way it digs. Again, I guess we're indifferent for a reason, right? We're good at digging. We're good at working out the right attachment and the right shape attachment for that machine. We'll work with whatever GET that we're kind of given, but we don't have a personal preference.
Yeah, I might add a little bit to that too, Brad. The bucket designers and GET utilises obviously around the application too. That's a big driving factor as well. If it's a loose stockpile type arrangement, then you're going to have a whole lot lighter GET than what you are if it's in a heavy rock environment, as you can sort of see in the background there. GET selection it really depends on the data and the application.
Next question. In regards to the HPX excavator bucket design, what are the advantages of that in reducing the dig cycle times?
That depends if we size it right in the first place and make sure we work directly with the customer to truly understand what they want. We've had a great win with a specific contractor this year in Africa at Indaba. It was nice to hear the end user actually walk up to our stand and say single-handedly the pass matching of our HPX bucket to the Ultima truck body that was supplied at a particular gold mine in the north of Africa was one of the single biggest benefits that they've seen, and they finished a contract early. So again, I guess it comes down to understanding, as Jamie mentioned at the start, understanding the challenges faced. The cycle times comes down to the bench height consideration, the fill factor consideration, the commodity that's mining. So we aim to get the right shape bucket to make sure that we've got 100% fill, and you get that pass match every single time to that truck.
Thank you, Brad. Next question. What makes the HPX excavator bucket quick to refurbish?
Go mute again. It's those panels. So you can remove the internal liner or the external or the internal cheek plates, left and right. The cheek plates don't always need to be done, but we would have a pre-rolled liner ready to rock and roll at the refurbishment center for when it comes down. It has the liner cut out, inserted, and quickly weld up. So there's a lot of considerations given in regards to the ease of access to remove in regards to the weld joint. And there's obviously the ability to prefabricate those parts to cut down on that time frame when it does come back to the workshop to be able to refurbish.
Thanks, Brad. I've got one more time for probably one more. Why is the superior wear life important in bucket design?
Because you don't want any unscheduled downtime. So if you have a attachment hanging on the front of your machine, the last thing you want is that machine to stop because of a bucket hold up. So obviously, other than changing out the lip shrouds and the teeth on the front of that machine, which is kind of given, if we build a bucket that says it's going to go a set period of time, we want it to achieve that. Now, the other side of that, we don't want it to, be over-engineered that it's super, super heavy and can easily surpass that. There's a balance, right? That comes back to that slide around total cost of ownership, about giving you maximum productivity, getting the absolute best dig, and making sure that the thing that's hanging off the front of your digger is, I guess, I wouldn't use the word light, but is designed to enhance that machine. You want that machine operating at optimum efficiency. The last thing we want is a machine to go down for bucket repairs. Typically, welding, hot work, high risk in the pit. That's the last thing we want. We build a bucket to go a certain design period. And one of the first things that we'll ask our customers is, what is your maintenance intervals, or what do you want your maintenance intervals to be? And we start from there and work backwards. So we don't want any unnecessary downtime on an Austin product because of we didn't consider it in the design phase at the start. So that is absolutely key. Giving you a bucket that is efficient, gives you the dig, and meets a certain maintenance criteria, so you don't have unnecessary downtime maintenance events in the field during operation.
Thanks, Brad. I've got one more that's popped up. How do you validate the fill factors and cycle time improvements achieved?
Jamie, you want to talk about that with the analysis we do?
Yeah, validation of fill factors, bucket volumes. We quantify through our DEM software, as we'd already mentioned. We also do have some trials on, well, we do conduct trials when we put a new product out in the field. We try to match the bucket or the new style of bucket alongside something that we know is digging and in the same area, and then we can engage some of those efficiencies through that. The DEM analysis too, it's not just about filling and getting bucket volume validation. It's also putting the bucket through a particle set, and then measuring the forces on the bucket theoretically to see whether we get percentage increases or decreases in inefficiencies. And we can relate that straight back to what the cycle times could be.
Thank you, Jamie. Thank you, Brad. That's all time we have for questions today. So that concludes our webinar. I'd like to give a big thank you to Jamie and Brad for sharing their expertise today. And thank you to everybody who attended. As I mentioned before, this is being recorded, and we will send everybody who's registered the link to this video, which will go up in the next couple of days. If your question wasn't answered, please send it through and we'll get it through to the guys at Austin. Look forward to welcoming you to the next AustMine webinar. Enjoy the rest of your day.
Thanks, Sam. Thanks, team.
Thanks, everybody.
Thanks, gents.